In the last video, when we changed the children array with a hash table, we ended up with a few breaking changes. Now here we have only implemented the insert operation, but what if we had several other methods? We would have so many breaking changes. Is there a way we could prevent that? Absolutely. And that is where the abstraction principle of object-oriented programming comes to the rescue. So in the second part of my Ultimate Java series, I talked a lot about object-oriented programming and abstraction. If you're interested in the topic, I highly encourage you to take that course. There's a lot of materials there. But very briefly, the abstraction principle says that we shouldn't expose the inner working of our classes to the outside. As a metaphor, think of a remote control. A remote control has a logic board. It's very complicated. We don't have to worry about that. We don't have to touch it. Instead, the manufacturer gives us a few buttons to control our TV. Now, if in the next model, they decide to change the logic board, they decide to optimize it or whatever, we are not going to get affected. We still have those buttons that we need to control our TV. This is the abstraction principle. Now, where in this code do you think we have violated the abstraction principle? On line 28, we're working directly with the children field. Earlier, the children field was an array, but the moment we changed this to a hash table, our code broke immediately. So this code, the insert method of the try class, is aware of the inner working of the node class. It knows that the children is a hash table that has these methods, get and put. What if in the future we decide to change the type of this field to something else, a data structure that doesn't have the get or put methods? Again, our code is going to break. Now, we have declared the node class as a private class inside the try class. So we can argue that it is okay for the try class to know about the internals of the node class. That is true. So potentially we could take the node class outside the try class. And then because these fields are private, the try class wouldn't be able to access them directly. But in this course, in this video, I don't want to do too much object-oriented programming. I just thought this is a great opportunity for me to demonstrate how you can write robust code that doesn't break all the time. So let me show you how we can apply the abstraction principle and prevent this problem from happening again. Back to our insert method. What are the services that we need from a node object? We need two services here. We should be able to ask this node, hey, do you have a child for this character? That is one service. Another service is we want to tell this node object, hey, add this character as a child node. How that happens internally, we don't care about that. The node object might decide to use an array or a hash table. It is none of our business. It is none of the business of the try class. So we go back to the node class, and here we add two methods to provide services that the insert method needs. So one of them is a public method, public boolean, has child, which gets a character. Now here we can write code like this. Return children dot contains key for this character. That is one service. Now we need another service. We want to be able to add a child to a node. So public void add child. We give it a character. And here we call children dot put this character. And this is where we create a new node object. So from the outside of this class, we simply call these methods. What happens internally, we don't care about that. If tomorrow we decide to change the type of the children field to an array, these are the only places that we need to modify. We have contained these changes to a single class. The consumer of this class, in this case, the try class, is not going to be aware of these changes. Okay? Now, back to the insert method. Instead of directly working with this field, we ask the current node object, hey, do you have a child for this character? If not, I want you to create it. So we call current dot add child for this character. There is one more service that we need from a node object. We should be able to get a particular child. So back to the node class, let's add a new method here. Public node get child for this character. And here we return children that get this character. Now, back to our insert method. This is the last line that we need to fix. So we call current that getChild for this character. Not only have we solved this problem, but also our code looks cleaner. It's more readable. It's like reading a story. If the current node doesn't have a child for this character, add it and then give it to me. It couldn't be better. So this is the abstraction principle of object-oriented programming in action. Next, we're going to implement the lookup operation in our try.